Hello ICCBIans, we hope you're doing great. In today's video, we'll walk you through some exciting activities we did during our robotics class in the computer lab. I'm Vizconde, joined by
Gabriella, Briones,
and Valerie
from grade 12 Ephesians. Without further ado, let's get on with the video. First, here are the list of the activities we worked on. First, we have 5 activities that focus mainly on the use of the serial monitor. The first one is the printing text in the serial monitor. Second is show the temperature readings. Third is checking if the button is pressed. Fourth is serial monitor as a remote control. And last is the light sensor logging.
Next are the 4 activities that focus on the use of ultrasonic sensor. For activity 1, we have the distance measurement display version 1, distance measurement display version 2, obstacle detector, and the parking assistance system.
We also have three activities for the IR proximity sensor, and these are the black and white detector, the proximity trigger siren, and count the passes.
For the DC motor, we have the MOSFET and the H-Bridge. The DC motor MOSFET contains 2 activities, which are the button control DC motor using MOSFET and the DC motor speed control using potentiometer and MOSFET.
For the H-Bridge, we have the motor power control, motor speed control, motor direction control, push button motor direction control, motor direction and speed control using push buttons and potentiometer.
A serial monitor is a tool in IDEs like Arduino that lets you send and receive text data over a serial connection. It's mainly used for debugging and real-time interaction with microcontrollers. For the first activity, the material needed is an Arduino Uno. Once the code is uploaded, the Arduino Uno read it and displayed it to the serial monitor that showed hello student. The second activity used the breadboard, temperature sensor, Arduino Uno, and wires. When an object was placed near the sensor, it measured the temperature and sent the data to the serial monitor in Celsius. The third activity used the breadboard, Arduino Uno, button, and wires. Pressing the button sent input to the Arduino, which displayed the button pressed message on the serial monitor. The fourth activity used an LED resistor, breadboard, Arduino Uno, and wires. Typing 1 or 0 on the computer sent commands to the Arduino which control the LED, turning it on with 1 and off with 0. The last activity used the breadboard, light sensor resistor, Arduino Uno, and wires. By placing a finger or flashlight near the sensor, the Arduino measured light levels and displayed them on the serial monitor.
An ultrasonic sensor uses high-frequency sound waves to detect objects, measure distance, or track movement by tiny wave reflection. It is commonly used for obstacle detection, level sensing, and proximity measurement. In our first activity, we use an ultrasonic sensor with an Arduino Uno to measure the distance to our palm, reading the output digitally by breadboard and wires. In the second activity, we use an ultrasonic sensor, LCD, breadboard, and wires to measure the distance to our palm with the result shown on the LCD. In the third activity, we use an ultrasonic sensor, breadboard, wires, and LED. The LED lit up when an object was near and the sensor displayed the distance. In the final activity, we use the 3 LEDs, a buzzer, and an Arduino breadboard, and wires. Each LED indicate distance, red for far, orange for medium, green for close, while the buzzer sounded based on proximity, using our palm for testing.
The proximity sensor detects nearby or distant objects using infrared light. It includes an IR LED and a photoresistor and is widely used in security, mobile devices, robotics, and automation. In the first activity, we use an IR sensor with an Arduino Uno, breadboard, wires, and a black mouse pad to observe how surface color affects infrared reflectivity, comparing black and white surface via digital output. In the second activity, we built a proximity alarm using an IR sensor, buzzer, LED, Arduino Uno, breadboard, and wires. The system activated the LED and buzzer when it detected a nearby object like a honey. In the third activity, we use an IR sensor, Arduino Uno, LCD, with I2C module, breadboard, and wires to count how often an object passed by. Each detection increase and count shown on the LCD or serial monitor.
A MOSFET is an electronic switch used to control or amplify signals. Common in devices like computers and power supplies, it helps manage voltage and current. In the first activity, we built a button-controlled DC motor using an Arduino Uno, N-channel MOSFET, push button, 9V battery, and DO mode. Pressing the button once started the motor, pressing it again stopped it. For the last activity, we used the same components as before, but we replaced the button with a potentiometer. This also controlled the DC motor.
An H-bridge is a circuit with 4 switches that controls voltage polarity, allowing current to flow in either direction. It is essential for driving DC motor forward and backward. Commonly used in robotics and motor control.
In the first activity, we use an Arduino board, L293T IC, DC motor, and a 9V battery to control the battery in one direction. Running it for 1 second and pausing for 1 second in a loop. In the second activity, we use PWM with the same setup to control motor speed. The Arduino gradually increase and decrease the speed, showing how digital signals can mimic analog control.
In the third activity, we use the same setup to reverse the DC motor's rotation by adjusting signals sent to the L293D. 2 Arduino pins control the direction by changing the motor's polarity through the H-bridge.
In the fourth activity, we added 2 push buttons to control motor direction using the H-bridge, 1 button for forward, the other for reverse, and the motor stops when there is press.
In the final activity, we added 2 push buttons and a potentiometer control meter, motor direction and speed. The Arduino reads the potentiometer's analog output and uses PWM to adjust the motor's voltage and speed via the L293D.
Through these activities, we understood how various sensors and components interact within our Arduino-based system. The serial monitor tasks were useful in getting familiar with presenting and controlling data, and the ultrasonic and IR sensor activities worked in demonstrating distance, motion, and environmental change detection.
These DC projects with MOSFET and H-bridge in learning to control the power, speed, and direction to the motor allowed us to better understand the collaboration of hardware with programming.
These activities demonstrated our ability to integrate hardware and software in solving problems, debug systems,